A couple days ago, my cousin stopped by and dropped off this Harman Kardon AVR10 receiver. It said it was just acting like it wasn't even plugged in, just completely dead. And I took the top off and had a look at it. Found that this fuse down here keeps blowing on power up, and F102, and I believe that is one of the two fuses in the low voltage supply that runs all the control logic and preamps and stuff, the plus and minus 15 volts. This is I think it's about 30 watts per channel, and it's kind of unusual in a way for a home theater receiver. It's got despite being a lower power model, it has binding posts for the front and center outputs, and then the smaller spring posts for surround outputs, which I would expect a receiver of this size to have this type of connector on all the speakers. But they've also got preamp out and main amp in connectors on here, which that's kind of uncommon for what I would call a modern home theater receiver compared to something like my old Marantz amplifier from the late 60s or early 70s, where these were more common. The construction is kind of difficult to work with. They've got the circuit that I need to access is underneath all this, which is soldered in place. They've got this vertical board and then some header pins which are soldered on to this board, which contains the surround amplifier circuitry, output transistors. These boards are in sockets, but those aren't the ones I need to get out of my way, so I'm pretty upset that this is soldered in. And I also did that same 90-degree angle construction back here, so kind of unusual. I can hear the inrush current when I turn this on. The transformer hums, so I can tell that it's charging up these big filter caps. I'm pretty sure it's just dead because of the low voltage side being out and not being able to run the display or basically any other control logic. So hopefully this bottom panel will come off and give me the access I need to the bottom of that board to start troubleshooting that circuit. Well, I was glad to see that the bottom panel came off without any trouble, and I've got plenty of room to work aside from that stupid stand-up board on the other side that's in my way. But that fuse is right here, so I've got to look at this circuit and follow it down to see if I can locate the short, and hopefully I've got a schematic that's at least readable that I can use as a guide. So let me see if I can pull that up on the computer real quick. Okay, the schematic is difficult to read, but at least I can see the main part of the circuit here. F102 comes in at negative 37 volts and goes through a regulator circuit with a current pass transistor, MPS A56Y, and a Zener diode, and that regulates it down to negative 16 volts, which then it goes off into the nest of traces all over the board. So I'm going to start by checking in here and see if any of these regulator components are shorted out. The current pass transistor for the negative 16 volts is Q163, which is right here, that MPS A56 transistor. I used the diode test function on my meter to test the voltage drop across both junctions on that transistor, and the amount of voltage drop appears to be way too high. It's almost 2 volts on both sides, where it should be more like 0.7 volts. And in fact, I had another MPS A56 transistor over here that I tested side by side as a comparison, and this one over here tested normal. So I'm kind of hoping that that transistor might have just gone bad out of fatigue. I didn't see any really apparent shorts between the output of that regulator circuit and the chassis, but I haven't checked to other voltage rails yet, so it's still possible that there's a short somewhere. But since this transistor is right here and easily accessible without taking everything apart, at least I'm pretty sure it is, I'm going to take that out and test it on my actual transistor tester. So it looks like I can reach that transistor. It's actually right there, so if that's all that's wrong, I won't have to take all this other junk out of here. Well, it looks like this MPS A56 is indeed toast. It's not even being detected by the tester here. So I wonder if I've got another one of these in my parts inventory right now. I'll have to take a look. Well, unfortunately I did not have any MPSA56 on hand. But looking at the data sheet, this is rated for 80 volts and 500 milliamps. So I've got several different PNP transistors here that may or may not do the job. So I've got to pull some data sheets and find the closest equivalent out of all these different ones I have. And hopefully one of them will work. Based on the datasheet comparison, the closest thing I have in stock is a 2N5401. It has the same style case, same pinout, and slightly better ratings. It's 120 volts and 600 milliamps, and the DC current gain is approximately the same. I think this might be just a hair less, but in this application I don't think it really matters. Alright, I've got that transistor installed and the fuse replaced. I'm going to see if there's any fireworks. No, it's still dead. Piece of crap. Probably blew that fuse again. Well, I thought for sure that that transistor would have been damaged and that there were other problems in that circuit, but it turns out the fuse didn't blow and neither did the transistor. In fact, the negative 16 volts is working perfectly now. I found that the fuse for the positive 16 is the one that's blown this time, so let me change that and go from there. Well, I decided to do a couple more checks before I changed that fuse, and sure enough there is a problem on the positive side now. The Zener diode for the regulator circuit is completely shorted. So that one I'm not going to be able to access without taking a bunch of stuff off. So I think what I'm going to do is unsolder this and try to take it out of there, and I'll solder a replacement diode on the back side of the board and test it that way. I can't believe I was able to get that out using some tweezers. Actually, I reached down through this little hole right here and managed to grab that diode, but the problem I have now is that's a 16 volt Zener, and the only one I have that's 16 volts are these big fat things. They're 5 watts. So I'm not even going to trim the leads on these. I'm just going to temporarily solder one to the bottom side to see if this thing's going to operate before I go and order one stupid little diode to finish this project. So let me at least hook this up temporarily. Temporary big ugly diode is in place, and I've got a fuse in there. Now let's see if anything goes pop. Oh, nothing went pop. In fact, I have display. So let me check some voltages and go ahead and connect the speakers if everything's okay. Ah, check this out. Boy, I hate not being able to just turn stuff up because YouTube might mute the audio on the entire video. But so far it's working perfect. So I've just got to get the proper diode for that and do a quick once over after I run it for a while and make sure it's stable. And maybe I can call this thing done. Obviously I'm not going to be able to finish it in this video because I'm just going to upload this, since this was basically the repair, and you know, put the right part in when I finally get it and get it out of here. It's got one of those motorized volume controls on it with the LED. I used to think those were so cool when I was a kid. Yeah, that right there is probably going to be enough to cause a copyright issue, but yeah, I think this one just might be fixable after all. Kind of a strange problem to have with the low voltage circuit going out like that. Usually when a receiver quits working, it's something to do with the higher power stuff. I think that's the first time I've ever had to fix the low voltage supply and not have anything, you know, shorted out farther down the circuit. You know, it's just the regulators themselves that were messed up. Go figure.